Anyways, today we have another show with Mr. Al-Khalili. He's on my list of things to do, and boy, I got a lot of stuff to do with Mr. Al-Khalili. Okay. Anyways, we're gonna talk about information today. Information. I think it's more about misinformation and disinformation. He receives misinformation, when he was in school and at the monastery, and he, disperses disinformation because of that. Okay. Thank you. Yeah. Okay, so here we go. First, let's start with a little review of what I did the other day. Okay, that was on the Slit experiment, so I'll just very quickly go through that. And here's the summary, essentially. Okay, Al-Khalili and cohorts have no idea how to explain the mechanism underlying the Slit experiment. You can't explain it with particles. Okay, and the main problem there, you can see, is that if we replace the slit, we remove the slit and put a hair, a human hair, or what I do, put a needle, which is air, then the particles have, the photons or the electrons have nothing to bounce against to come into the screen, to interfere with each other. Okay, so this is the issue. The issue is you need, according to quantum, if you're going to send those little particles, they have to bounce against the windowsill, okay, of the slits. And of course, when you do that, when you remove that, well, then what's your explanation? Especially if, like I showed the other day, you can reproduce the slit experiment with just a needle. Newton really Thomas Young, he did it with a human hair, but he got that idea from Newton. Anyways, if you put a needle, you can do it at home. Just shine a laser, monochromatic light on a needle, and at the far end of the wall, you'll see the fringes. Okay, so do it at home. Don't take my word for it. Don't take Thomas Young word for it. Okay. Transverse wave is not a valid medium for the purposes of physics, so you can't use the transverse wave. Okay, so that's the problem there. Let me get this thing here. Okay. So why? Because all those little lines that you see there, those are vectors, mathematical vectors. They have magnitude and direction, upwards in this case, or sideways, 90 degrees. So what they're doing is they're putting something on the screen. You say, oh, okay, I see, that's a wave. No, it's not a wave. What you're staring at is moving vectors. That's how idiotic the so-called transverse wave of mathematics is. Okay, they have moving vectors. So that's not a valid object. They have to tell us what object is going to be doing the motion. And, of course, a lot of mathematicians use this more idiotic notion, saying, well, light doesn't need a medium through which to travel. That's not the question. We don't care what it needs to travel through. But if light travels, only objects can travel in physics. You have to identify the object that travels. You can't say nothing is traveling. So we don't care the medium in which or through which light is traveling. We don't care about that. We're talking about light itself. What is the medium, the mediator, the agent that mediates light? That's what we want to know, because otherwise you can't talk about travel. Only objects can do travel, motion. And mathematicians have not learned, a lot of them have not learned that in many years. Okay, they never thought of applying Popperian falsifiability to the particle hypothesis. And that's so weird, because here they talk about falsifiability and they like Popper. Okay, so why don't you apply it here? You can't explain a single phenomenon of invisible phenomenon of Mother Nature's. And if you can't explain a single one, then maybe it's time to brainstorm a new assumption. They never did that. It never crossed their minds that they could do something other than particles, pressure, pull, that push. Okay. Okay, so under the rope model, we have no problem with the slit experiment. We just make a new assumptions. The assumption is that all atoms are physically interconnected. Okay, there you see the model. Two atoms are doing their quantum jump, tied by what we call the electromagnetic rope. as the atoms pump back and forth, expand and contract, they torque the rope. All atoms in the universe are interconnected, and that's different than what quantum or mathematical physics proposes, which is discrete particles. And under the rope model, yeah, on the bottom you can see how we explain it. When you turn the light on, all atoms are already interconnected before you turn the light on. But when you do, all you do is increase the frequency, and then all you have to do is apply what you see on the bottom right, which is constructive and destructive interference of the rope. If the rope impinges or arrives, it doesn't arrive in the sense of traveling, but it just it's hooked to the atom on the other end, because those same threads form the atom. Okay, so if they impinge on the electron shell where they fork out, if they impinge in phase, well, then you have constructive interference. They pump the atom stronger. Okay, and then, in other words, they relay the high frequency from the source. And if they are out of phase, well, then you have destructive interference. Okay, so it's a physical mechanism. What you have is a rope, and that's what's different from mathematical physics. And then I also quickly went through the problems that mathematical physics has in general. Okay, these are all fatal problems as I see them. Al-Khalili and his cohorts dismiss physical interpretations as petty philosophy. But then the question is, why did they attempt to explain the workings of the universe in the first place? I mean, they're the ones who were trying to give a physical interpretation and pass this information on to the general public. But when you put them against the wall and say, hey, it don't work, or whatever you're proposing is irrational, they say, well, yeah, it's just philosophy anyways. So why did they attempt it in the first place? Why didn't they say, look, we can't tell you anything about the real universe. We can't explain it, how it works, and so don't ask us. All we can do is describe it. Then it'd be okay. But they try to explain it, and then they deny their explanation. They got this fine print. Okay. Al-Khalili and his mathematicians have no idea of the difference between a description and an explanation. They use these words interchangeably as if they were synonyms. Math can only describe and has no power to explain. Therefore, spiritualists, religious-minded, irrational individuals have taken over science and physics in the last 400 years and converted science and physics into a body of descriptions. So if you ask any of them, they say, oh yeah, science, physics, that's all just a mathematical calculation, and all it is a description. And that's what we have today, equations and descriptions. And so far we have only irrational explanations for how this universe works, especially the invisible stuff that Mother Nature does, like magnetism and gravity. And mathematical physics has no explanation for mechanisms of any invisible phenomena of nature today. You'll hear about nonsense such as black holes, dark matter, particles of mass, Big Bang creationism, particle at two places at once, uncertainty principle, complementarity principle, duality, all that nonsense. That's all irrational. Not one survives rationality, and science is about rational explanations. Therefore, none of this belongs to science. Okay, none of these so-called physical interpretations, explanations, or what do we call them, philosophy? None of this philosophy belongs to science. The general public is unfortunately blindsided to this state of affairs. The typical layman believes that all is well in science and physics because we wouldn't have all this fantastic technology if quantum and relativity were wrong or incorrect. So that's the state of affairs. Unfortunately, the general public is not aware that these guys don't know nothing. They say, hey, we got all this technology. They must know something. No, they don't know nothing. We didn't develop the technology through through Harvard and Cambridge. We developed it at the lab by doing trial and error. And whatever math they did, at the think tanks there, well, that math is just math. That's it. That's description. They still don't have an explanation. The fact that, again, I showed the other day that you can lift a car with a magnet doesn't mean you understand what a magnetic field is and how it does that magic trick. So those are two different things. And the part that they cannot answer right now, we saw Richard Feynman squirm when the BBC asked him a few years ago to explain how a magnet works. Well, he had no clue. And obviously he has no clue, and neither does anyone today in mathematical physics. Only here do we have a physical interpretation for how a magnet physically attracts another from a distance and repels it. We can explain it mechanistically. Whether you believe it or not, that's your personal issue. You know, it has nothing to do with science. That's your belief. But we have an explanation that you can objectively see, understand, and take home with you. Okay? Mathematical physics does not. Okay, next up, where are we? Let me do a little thingy here so that I organize myself a little bit here. Just a second here. Okay, so anyways, next up we go into Al-Khalili and his notion of what? Of information. This is what Al-Khalili is going to talk about today, or through me, right? He's going to talk about information. And what does he say? Well, he talks about manipulating it. I didn't think information was an it for the purposes of physics. Physics and it is only a noun. And what is a noun in physics? Only objects and serves as its and as nouns. No concept may function as an it. You can't point to it concept. You can only point to you can point to objects. You can't point to concepts. Okay. Writing codes and computers revolutionized our understanding of the universe. Well, I don't know if they revolutionized his understanding of the universe. They allowed us to do technology. In other words, we were able to make progress thanks to these things, writings, codes, and computers. We were able to do things with that. And we had progress as a result of that. Does that equate to science? No, that equates to technology, not to science. This guy still has no understanding of the universe. So what is he talking about understanding the universe if he doesn't understand squat about the universe? Okay, he's still dealing with black holes, dark matter, and other spirits. So no, he doesn't understand the workings of the universe, the invisible workings of the universe. They're still talking about gravity waves out there and black holes and proving black holes, dark matter. They're trying to prove it because they need to have something to do for the next few years. So dark matter is high on their on their list there. But got all kinds of problems in these situations here. Anyways, in a cosmos collapsing into disorder, like something was collapsing into disorder here a minute ago here, information can be used to create order and structure. Order and structure. What is order? How do you create structure with information? You can create structure with your hands, maybe a robot working, maybe on the assembly line, you can do that, but you cannot create structure, meaning modify structure. You can't even create structure. Not even God can create structure. You can't create structure like from nothing and suddenly make, length, width, and height, and suddenly you create something. That's creating structure. Modifying an existing, not modifying a tree into wood and wood into chair. Yeah, we can do that. We can convert atoms into something else. We can mold them, okay? Now, whether that's creating order, I don't know. Order is an opinion. What is order to someone is disorder to someone else. So they talk about order, entropy, all this nonsense words that mathematics has created, which has no bearing on science, on explaining things. Okay, you're not going to explain anything about the universe by talking about order. What is this? Order? Anyways, what does Jimmy do? Well, he says he's going to Harness. He says information has been one of the subtlest and most difficult concepts that science has had to grapple with. Grapple, that's already sounding very kind of interesting, you know. Harnessing it has been a long and difficult process. Well, yeah, if it's a concept, it's very hard to harness a concept. I mean, did you ever try to put, a harness or a saddle on love? Yeah, you can't harness a concept. And, you might say, Bill, you're very picky with a language here, aren't you? Yeah, and I'm going to show you why. I'm going to explain to you why today, why I'm a little picky with a language. Okay? And so keep that in the back of your mind. It's going to be underlying my talk today, okay? Anyways, here Al-Khalili goes and talks about order. Okay. We are surrounded by order. Order. Over the last 300 years, we have developed amazing new ways to harness energy. Again, harnessing energy. But all these structures like buildings and so on, we see around us are just one type of visible order that we've created. Order, I thought they were just structures. What is this order? Order is in the mind of the beholder, not out there. Order is in here. Okay? That it's the guy who's looking at that and say, oh, how beautiful. Well, what is beautiful? Is a nice landscape with blue skies, is that beautiful? Well, maybe it's beautiful for you. Maybe for someone else it's not beautiful. Maybe for someone else total darkness is beautiful. I mean, beautiful is an opinion, and so is order. What is order? When we take sand and turn it into a glass, have we ordered it? No, we just converted one object, which in this case is sand, into another object, which is glass. That's objectively what's happened. The order part is an opinion. Okay, it's again in the eye of the beholder, the mind of the beholder. There's another type of invisible order. We have invisible orders now that we're only now beginning to understand. Well, hopefully we understand them, okay? Something that nature has been harnessing for billions of years. Information. Okay, so we're harnessing information. We're just beginning to understand information. What is he talking about? What is this information thingy that he brings into physics? That's the main point here, okay, that he's bringing all this stuff into physics. Well, I think Al-Khalili is a caricature of science, okay? And why? Because he goes in there and one of the first things he says, right? Information exists. Exists? Love exists. Information exists. Data exists. Hate exists. Grace exists. All these concepts exist. No, in science, we cannot say that a concept exists. It's irrational. So if he's going to be talking about physics, which is what he's trying to do here, he's trying to talk about physics. First, he's introducing information which has nothing to do with physics. And second, he says it exists, a word that exclusively belongs to physics. Physics is the science of existence. Physics only tries to figure out and explain that which exists. In other words, tries to figure out what exists and how it behaves. Why it behaves the way it behaves. That's what we're trying to figure out. That's why it's the science of existence. It only deals with things that exist. And for sure, information doesn't exist. You can't say that a concept exists. And what Al-Khalili didn't start out the way he should have started out is by defining what an object is, what a concept is, and what exist means. If he would have done that, would have been great. But no, he's now using these words, and where do they come from? They come from ordinary speech. So he's introducing this language into his dissertation, supposedly a rational physics scientific definition, and he's introducing words of ordinary speech. He's not going to define them. He doesn't know what they mean, but he's going to use them, thinking, well, you know what they mean, don't you? No, I don't. Please define them. Okay, so it says information exists everywhere in our world. Well, I don't see it. Where is it? Are these spirits, ghosts that are flying around? Is that how they exist? I don't know. Our brains are filled with it. Jesus Christ. Mine's filled with blood, neurons. His is filled with information. maybe it's sand that he's got between his 2 ears. I don't know. Which it and we are we constantly exchange it between each other. No, we exchange maybe coins, dollar bills. We exchange, if you're in a garage sale, you might exchange, some bills for a chair or whatever you're selling there, right? That's an exchange. But exchanging information, no, we don't exchange information. Not in physics. In physics, we do not exchange information or transfer money. There's no physical object called money. Okay? Money is a concept. We don't transfer money in physics. In everyday speech, yeah, we transfer money. We go to the, Western Union or PayPal and we transfer money. Not in physics. We don't transfer money. Transfer means you're going to grab a hold of something and take it to somewhere else from A to B. You can only do it with objects. Money is not an object. Coins are objects, bills are objects, money is a concept. And people always introduce ordinary speech into physics, so they lose track of all that. That's why they use the word exist, because they, again, introduce the vague ordinary speech notion of what an object is and what exist means. That's why these words had to be defined very specifically, because people just got off on tangents because we never defined these terms. Okay? But information has been one of the subtlest and most difficult concepts that science has had to grapple with. Concept. What did Jim just say? That it's a concept. Okay? Now, if I say dog, he would not say, well, it's one of those difficult concepts to grasp. No. Dog, you point to and say, that's a dog. It's a thing. Concepts we might have problems grasping because you have to define it. Objects we don't define. We don't define what a table is. We point to a table and say table. That's how it's presented in physics. Then you can describe it later on and say, yeah, it's got 4 legs, one board, whatever. You can describe it later on, but first you point to it and name it, table. And you can't do that with concepts. You can't point to information. So this is where good old Al-Khalili is going to run into trouble, because he's going to be bringing all these words of ordinary speech to do his scientific dissertation, his dissertation on physics regarding this thingy he calls information. And yeah, information, because we're in the disinformation age or misinformation age or the information age. I don't know which of the information ages we're in now. I think we're in the disinformation age. The word information has become, paramount. It's risen to the top of the mountain. So information is a word that's on everybody's mind and mouth. But we're using the notions of ordinary speech and we're bringing them into physics and talking back and forth across that line between ordinary speech and physics. That's where we're going to run into trouble, and that's where Jim runs into trouble, because he doesn't draw a line. So he keeps going back and forth. You don't know if he's talking ordinary speech or real stuff. Okay, that's where the problem's going to be here. Okay. So yeah, he calls it a concept. That's important. Keep that in mind. He calls it a concept. Okay. Where does he go next? Well, first we got to mention that he is definitely a caricature of physics. Okay, because it's not only that he talks about information as if it were a physical object, even though he calls it a concept. They talk about transferring energy. What do you mean you transfer the energy? Energy is a concept. How do you transfer energy? Do you pick it up with tweezers and throw it across the window, or how do you transfer energy? And energy says morphs into a virtual particle. A couple vids ago I talked about that. Okay. Energy also turns into mass, and mass is taken by the majority of these mathematical physics as a physical objects. They say that energy turns into mass, meaning this non-thinking, this spirit, right, turned into a solid, turned into mass, which they insinuate that is like a standalone object suddenly. That's what that E equals mc squared stands for. The energy turning into mass and mass turning into energy. So they go back and forth across this line. The body turns into a spirit and the spirit turns into a body. Okay. Then they say mass pulls on a star. Obviously, if they turned mass into a physical object, they can say that now there's this big mass, this infinite mass called a black hole, and it can pull on a star. Oh my God. So now we have this concept pulling on a thing, on a star. We have the spirit pulling on a star. And they also talk about a field pushing two magnets apart or bringing them together. Is field a physical object? No. It's a value at each point in space. That's a mathematical concept. It's not a standalone object. There is no physical object called field. Then they talk about time dilation. They're going to dilate time. Okay, then they say that this time thingy, prevents the Earth from leaving the solar system because you got this curved time that I guess comes up against the skin of the Earth. Okay. Light is the waving of nothing. You'll hear that often out there. What do you mean the waving of nothing? How can nothing wave? It's got to be a something to wave, not a nothing. Okay, that's okay in mathematical physics, not in science. Empty space is made of particles. So whatever is inside the atom, which is they say is empty space, is a bunch of particles. That's what they're telling you today. So what did we learn? We have Mr. Rutherford. He said in 1919 that an atom is mostly empty space, and these people are telling you now that empty space is a bunch of particles. So an atom is mostly a bunch of particles. Great. Why doesn't it stop? Why does it stop the gold? The gold foil. Why doesn't it stop the rays from going through? Why don't all the rays bounce back if it's full of all these particles that make up empty space? So yeah, we're back to square one. We don't know what an atom is made of because it's made of empty space, which is made of particles. And then we have the strong nuclear force. I showed it the other day. It's a bed spring that holds the quarks together, the gluons. So that's how they illustrate it, okay? Because they have no other way of showing how a quark is pulled towards another one. They never show the gluons pushing on the quarks together. And you know why? Because they would not be able to explain what pushes on the gluon to begin with. Why would the gluons push inwards? Okay? You get the problem. The problem is you have to pull from the inside, not push from the outside. Because if you push from the outside, then the person's going to ask, well, what's pushing the gluon? What's pushing the strong force? And these are the issues that they have. They don't answer those questions. They just show you a little picture of a little spring there, which I showed the other day, pulling the three quarks together to make a proton or a neutron. And then you look in the standard model and say, okay, let's see. I want to see the bed spring that I just saw, the gluon. And all you see the letter G or whatever. You'll never see a gluon in your life. Okay, not a picture of one, right? Okay, and I don't mean the real thing. I don't care about what Mother Nature has out there. If there's a gluon out there, I just want their version of it. The one they're going to use to do their presentation, their dissertation with. Show me your gluon, not Mother Nature's. I don't care about Mother Nature's. I want to see your gluon so I can understand you. It's like the guy who presents God and says God made the universe. Okay, I want to see your God. I don't care about the real God, the one that's out there. That's okay. That's fine. I love him. I want to see your God. What are you going to put for God? And that's when they run into trouble. Some say, no, he's all intelligence. If I knew what God looked like, he wouldn't be so great. And all that, all that run around. Okay. Yeah. So this is what Al-Khalili will be doing today. Okay. He's going to take info and he's going to turn it into a rock. How's that for magic? Okay. You got to take a concept, turn it into an object. Okay. So that's essentially going to be his argument there. Okay. Okay, so let's get going here. Goes through a little bit of history to introduce the subject matter. And essentially he says, that the power of information would first be glimpsed about 5,000 years ago. He started with Sumerians, saying that they were the ones who invented writing, or at least were the first. It's the first extant example we have of writing. Maybe there was someone before the Sumerians that had writing. We don't know, but you could even say the caves in Lascaux where they made this little what was it uh, mammoth on this. I mean, it's a drawing, so you could say, well, that's pictorial uh, wording of something. You're putting an image of something on the wall. I guess that qualifies as writing, or at least as art, if that could qualify as writing. But otherwise, we got to give credit probably to the Sumerians. Okay, invention of the writing. What is it? The written word. For the first time, we have the written word, at least in a civilized way, I guess, right? Writing is the transmission and storing of information. How do you transmit and store an object, a concept? I thought information was a concept. He said it's a concept. Now he's saying he's going to be sending it. He's going to have this thing move through space from A to B, and he's going to store it, I guess, in his locker or in his basement. I don't know. So he's using this terminology. And again, you might say, well, Bill, you're being too hard on him. You're going too lengthy on semantics. Keep this in mind. They use it for energy. They use that word for mass, for force, for time. They reify all these concepts. So it's not like I'm being picky because I'm saying, oh, look, he's doing this with information. They do it with everything. They do it with all concepts. You don't have a single object in all of mathematical physics because they have no use for objects in all of mathematical physics. That's why they're the wrong people to do physical interpretations of the real world. But this is what they, this false advertising they give you, that's what they do, that with their equations they can interpret how, meaning why, not the how, the description, but the why, the explanation, the mechanism of how Mother Nature runs her shop. And so this is where we have a problem, because these guys are coming into physics. They're stepping over the line with all their gibberish math, and they're saying, oh, we can tell you how this universe works. Well, yeah, tell me how. And then they tell you the how, but they're telling you the description, not the explanation, not the mechanism. That's where we're having a problem. And part of that deal is this information deal. They bring this information that has nothing to do with science or with physics, but they bring it in there. Remember Al-Khalili works for the BBC. He's their poster boy for physics, science, whatever nonsense BBC does. And so, yeah, he supposedly is brainwashing the masses or passing on to the masses the nonsense he learned at the monastery. And the BBC likes that and says, oh, we have a scientist. Let him tell the public how this whole thing works. And so what does he do? He tells you nonsense. And then when you put him against the ropes and start pummeling him, he says, oh, that was only philosophy. You shouldn't take it seriously. You shouldn't take it literally. Okay, words are life support capsule for information. Okay, words allow ideas to live over time. Yeah, time, as I show there, ends with the 21st century. That's when time's going to end for us. We're very close to extinction, and that's my take on that. You don't have to believe me. All you have to do is, I hope, understand the theory of why we're about to become extinct. Okay, money is no more, trade is no more, no one produces food, we all die. That's essentially it. 2 seconds. Information is going to die with us because information is here, not out there like Al-Khalili is going to try to tell you. He's going to try to give you the idea that information is a standalone object that stands out there, outside of the brain. Why? Because once we invented writing, it was no longer in here, now it was out there. That's essentially his starting point. That's how he starts his dissertation. That's what he wants you to understand. Okay, says words allow ideas to live over time. I like, Shaka Zulu's version a little more. And, Shaka gets one of his fellows there, Pete, right? And he asks him, what do you do for a living, in civilization? He says, I teach children to read and to write. Shaka says, what nonsense is that? Writing, is used to transmit ideas, feelings over great distances. Shaka, I have messengers for that. Okay, and Pete says, but this ensures that what you say here is heard there in exactly your words. And Shaka says, I'm already assured of that, Pete. If my messengers misrepresent me, they're dead. Now, how's that for communication? Okay, for transmission of ideas. So I like Shaka, the way he handled that situation. He said, yeah, I send my warriors, and if they don't transmit my information verbatim, well, they die. Okay, I like that. That's good. Okay, anyways, Al-Khalili says that Sumerians invented writing. That's what that scribbly stuff that you see at the bottom. That's what it looked like, called cuneiform writing. Okay, they had all these signs or hieroglyphics, and they not only had letters but numbers. Okay, and so because they needed to transmit ideas, and obviously writing enabled them to do that, no doubt about that. Okay, but I want you to understand that there were other cultures, okay, that developed this independently in different parts of the world. You have the Aztecs and the Incas there. You have the Vikings on the upper right. You have the Namibians in Africa on the bottom right, and on the what is it, on the lower left, you have the Chinese. Okay, this is ancient writing. Okay, I don't think they write like this anymore, but this is how writing started in different parts of the world. What am I saying with this? Well, I'm saying a couple things. First, that writing was in the works. In other words, we could not have avoided writing. It was in the cards. Mother Nature already programmed into us, like the brain we developed. I think it was inevitable. I think someone within the hominin line, if you want, would eventually come up with high intelligence. In fact, it was already in the works. The Neanderthals were no dummies. They had brain sizes as big as ours. Maybe they didn't get to develop all the technology we did because they stopped at hunter-gathering. That's when they died. But I'm sure if the Neanderthals would have continued, another million years or whatever, maybe they would have developed society further and further, going from clans to tribes, tribes to villages, villages to cities, technology, services, and extinction. Right? Okay, so here's my history of man. Some of you are familiar with it. Yeah, we were, for the most part, for maybe 200,000, 300,000 years, we were hunter-gatherers. At some point, around 10,000 years ago, these numbers are very, very general. Okay, we developed farming and domestication of animals. And then about 200, 300 years ago, we started with the Industrial Revolution, went into manufacturing, and about maybe 40, 50 years, this is an old graph, by the way, maybe 40, 50 years ago, I think it's around 1980, we probably made the transition. I think it was 1979 when at least the United States and some other countries like Sweden, perhaps, made the transition from manufacturing into services. In other words, more of their economy became service oriented and less of it manufacturing and agriculture. And China, which is lagging quite far behind, did it just a couple years ago. I think 2015, 16, or 17, one of those 3 years, services for the first time surpassed manufacturing. And which one is the manufacturing center of the world? China. And now China is not replacing, but services are taking over because they can do manufacturing more efficiently with fewer people, and it's an ever smaller portion of GDP of their economy, and more of it is becoming services, and more workers are moving into services. What is services? Unemployment. That's what services is. Okay. That's the definition of services. God looks down on the earth from up there from heaven. What does he see? Well, he sees all the construction stuff, all the stuff we made: ships, boats, airplanes, cars, houses, roads. He sees all that. He doesn't see services. All those are promises. Never happened yet. Insurance, you'll be insured when you get sick, maybe, if the insurance policy covers it. Okay, where do we go from here? Okay, this is where Al-Khalili takes information outside the body. So this is an important step here, okay? He suddenly takes this, he says, information could now live outside of the human brain. My God. Love exists outside the heart, and you take it out and you have love over here now. Okay, this spirit called love. And somehow his information also lives outside the body. Okay? I hope I'm still alive there, guys. Let me know. I'll check just in case. Always like to check because sometimes I end up talking about half an hour until I figure out that, I'm not communicating. Yeah, I think I'm still there. Okay. Anyways, let me know if I get cut off. Sorry for the interruption, but I do want to double check all the time. Okay, so he said it could endure over vast lengths of time. Okay, yeah. You write something, even if you do it with hammer and chisel against the rock, I guess it stays there. Maybe all forever. I don't think so. Sometimes it gets wiped out by time. So it endures a long time, but not forever. Okay. Information can be changed from one form to another form. Again, these subtle words, we have to be careful because they talk about form, and there is no such thing as form of information. Those two words, one. Okay. Information and form don't go together. Concepts and form, concepts and shape, they don't go together. They never mix. So when they talk about form, it turns on a lightning rod in my head. I catch these things instantly. I'm so touchy about these terms that they use, okay? Anyways, from something that existed, that's what information is, as spoken sounds, okay, that's something that existed, into something that existed as symbols. You see what's happening here? We don't, sound and symbols are not somethings. And again, if he would have defined what a thing is, what a something is, what an anything is, then, or a body or a whatever, an object, that would be okay. But see, he hasn't defined that. He's just using words of ordinary speech. He's bringing in them into physics together with this word information, which he also brings in forcefully into physics. It has no business in physics, but he's bringing it anyways. And to back it up, he's bringing all these terms of ordinary speech, which he hasn't defined, thing or something, right? Exist, right? He's bringing all these terms in here, form. He's sneaking them in there. He doesn't even realize it because he thinks he's being rational, right? And yeah, you can't talk like that with information, not in physics, because you can't make your case with information in physics. Okay, let's continue here. So where does he go next? He said you could send messages only as fast as you could send objects. Okay, so this is up to the 19th century. All they had was, stuff like the Pony Express and, the signal guy there. It was all relying on objects, on matter, okay? And it only could go as fast as you could send matter, essentially, But that changed in the 19th century. Why? We moved into electricity. And we started playing around with electricity. And from electricity, we started playing around with the telegraph, okay? And this is where we made the big jump, 19th century, okay? What happened? We went in there and invented, we developed, because it's not like you invented it one day. The telegraph was developed over a long period of time. They had many instances all the way from the end of the 18th century where they tried different things with electricity, and they found out that they could do some things, but none of it was practical. You could not make anything useful out there, and so that was the end of the testing. of the manufacturing process or the research and development of the manufacturing process. It never got off the ground in the 18th century. 19th century, they played a little more with electricity, and they finally came up with a telegraph. And by 1838, you have Samuel Morse. He comes up with the Morse code, which, by the way, is not the same one we use today. It was modified in the 1850s, I think it was, and we have a modified Morse code. But essentially, we call it the Morse code because it's essentially his code, the dit dit dot dot, right? That's what it is. And with that, they made a lot of progress because now they could send things through the wires, and they started putting these trees everywhere where they had all these birds hanging from these wires. And we could transmit along the through from one city to another through these cables. And that was magical. That was magical because suddenly people were able to communicate. In fact, the phone came a little later from that, but just about the same time. We could communicate not only information, but also we could talk over the phone, right? And we could communicate with someone far away. And so suddenly we could carry, again, he uses the word carry, okay? Carry information at incredible speeds. Now, we didn't carry them with electricity, okay? And I'm going to go at the end with a little summary on that issue. So keep that in the back of your mind. And so he asked this rhetorical question: was info at the zenith of, at the end, right, of the 19th century? Was that the maximum point we could reach? And no, what came in the 20th century especially was the computer. That's where he's headed with all this, because he's got to justify why we have so much communication, so much information. We're in the information age, information society, or whatever we want to call it. I call it the disinformation society, okay? And so we got to find out how we got from the 19th century to the 20th century, okay? From the telegraph and the telephone to, the cell phone and the computer, okay? Okay, and one place where it started with this gentleman, Maxwell, and right after the mid 19th century, he came up with this demon thought experiment. And it says, heat is the motion of molecules, okay, vibration of molecules, okay, no problem there. The hotter the heat, the faster the molecules are moving. That's Al-Khalili statement there. Just by having info of molecules, you could create order from disorder. I don't know what he's talking about. What do you mean you create order from disorder? Well, he says, he says, the reason we understand the true connection between information and reality, information has something to do with reality, okay, is because of Maxwell's demon, okay? The demon could create order in a box of air that started out with disorder. It could do this without expending any energy. What the hell is he talking about? Well, for this, we got to look at Maxwell's demon, okay? What is this little thought experiment about? But I want you to keep in the back of your mind the fact that he's using words such as energy, a concept, reality, which he hasn't defined, talks about creation, create. If you use the word create in terms of concepts, creating ideas, that's fine. If you want to use that term, okay? You can say come up with also. I came up with an idea. I created an idea. Okay, if you want to use the word create in that context, no problem. It's got nothing to do with physics. In physics, we do not create. The word create is forbidden because the word create means one and one thing only. And that means that you turn nothing, empty space, vacuum, and you turn it into something. Three-dimensional or two-dimensional something. You turn it into a square. You turn it into a cube. You turn it into a tree, a dog, a house. You can't do that. You can't turn nothing, that which doesn't have borders or boundaries, that which doesn't have shape, and you can't turn that into something that suddenly acquires shape, length, width, and height, or length, width, or width, height, or length, height, any of those. You can't do that. You cannot imagine that metamorphosis, okay? That is black magic. Not even God can do that, okay? And so he's going to use that terminology, and that's a critical terminology because He's going to make his case on that. That's why it's critical. You can't later dismiss that and say, well, you're just playing semantics, Bill. You're just harping on grammar. No, this is not about grammar. This is about interpretation of what he is saying. Okay, so I'm not going to let him off the hook on this. Okay, anyways, so what is this famous Maxwell's demon? Okay, well, we have this hot area and the cold area, and we have a little demon. He's going to open a little shutter there. He's going to let the cold go into the hot, or the hot molecules of the cold area into the hot region, and he's going to do the opposite. He's going to let some of the cold molecules of the hot regions go into the cold. Okay, so very simple, nothing more complicated than that. This thought experiment has more ramifications than this. I'm just going to go swiftly over this because that's all that Al-Khalili does. His point is the following. This is the point that he's trying to make. That's why I don't go any deeper into Maxwell's demon. Okay, it's got more than that, but we're not going to deal with that here. I just want to make the point that Al-Khalili is trying to make. Okay, and this is his point. Okay, he says the demon is using nothing but information to create useful energy. Okay, but this doesn't mean that you're getting something for nothing. Okay, deletion. Listen to this. Deletion of information requires him to expend energy. That's why he doesn't get something for nothing. Okay, the demon needs to keep a record of which molecules are moving where. Okay, if the recording device is of a finite size, at some point the demon is going to have to erase it. Okay, that's an irreversible process that increases the entropy in the universe. Okay, if it's finite size, he's going to have to. It's too full. It's too full of energy. He's got to erase the information. Okay, and that's where he expends energy. I thought he expended energy, the devil did, when he raised the little shutter already. I thought that requires expending energy. But I guess the devil does everything by magic. But what's the point here? Well, the point is that he's saying that energy is somehow related to information. Okay, those two are concepts. I have no problem there. But, remember, energy can turn into mass. Mass is a physical object according to mathematical physics. Mass means a rock. So we're turning information into a rock. That's more or less what we're having here. Okay, that's where I tremble because I see it coming already. I see him trying to sneak this thought in there, his religion, okay, into science. Okay, so we're working into the 20th century. Okay, and he's got to justify what progress we made in information in the 20th century. And for this, he starts with a little bit of history, and he talks about two of his heroes. One is Alan Turing, and the other one's going to be this fellow Claude Shannon. Nobody knows him. And what they did was introduce the zeros and ones, the ones that allowed us to do, bits and bytes and computing. Okay, so this is where he's coming from because that's all information. Okay, I worked in the information business many years, so I know a little bit about this. Okay, and essentially he says that Alan Turing came up with this great thought. He says that computing requires two components. Okay, I thought we knew this all along, but he gives the kudos to Turing. He says data and what to do with the data. Those are the two components. 1 + 1 = 2. The ones are the data, but the plus is what to do with it. Okay, so those are the two components. And Girl Turing discovered this. And Turing was a very important guy for the British intelligence service during the war. Okay, he was hailed as a hero, but he was homosexual, and because of that, they forced him to change his sex. And he either died trying or committed suicide. They don't know if he had an accident, but he swallowed what he wasn't supposed to swallow and died. Anyways, Turing, they re-established his name later on, I think 1989 or 1990s. Anyways, he said we have to create a language that machines can understand, because he did work with the intelligence service of Great Britain, MI6, I think, and tried to decipher what the Germans were doing out there. Okay, and then Claude Shannon came a little later, mathematical theory of communication, and he talked about a system being in two states, not about the first two that Turing talked about. He talked about a binary system. The info could be represented with zeros and ones, known as a binary digit or bit. Okay, and that's the smallest unit or the smallest quantity of information. And so Al-Khalili gives credit to Turing and Shannon because they showed us how to measure and quantify information. Okay. Okay, so where do we go from here? Well, if I can get this thing up there. Here's the part of the problem. He says, well, how do you describe, and again, he uses the word describe, okay? Just something as simple as filling a glass with water. I mean, all the things that are going on in there, and we only see part of it. We don't see the whole picture, all the little molecules, all the atoms, everything that's going on there in there. We don't see the light, you know, the ropes. We don't see any of that. All we see is just something very, very, what is it, general. Like when you watch a movie, you don't see all the little frames in between, okay? We can't see all of them, so you see, you know, this paintbrush, this broad paintbrush just painting across the wall. You don't see all the little lines that the paintbrush made. That's more or less what he's going to talk about here. He said, we see only a fraction of the complexity of nature. Any event contains a spectacular amount of information. Contains information? I thought information was in here. Keep that in mind. Keep it here. Interplay between billions and billions, sounds like Carl Sagan, of atoms, the amount of bits you would need to describe, he uses the word describe, this is unimaginable. Yeah, okay. If you want to describe with a computer, every little drop, God's computer must be breaking. I can imagine that humongous computer God has there to keep track of all the little motions of every little particle. Yeah, we can all understand that. It's got to have even time-wise and also space-wise to say it in those terms, okay? It's got to be a lot of information if we were to control every little thing that happens that if you want to describe. We don't need that in physics because in physics we explain and all we need to do is explain a mechanism. So we do not need to know all the atoms of the pulley or of the rope of the pulley going around it to explain how a pulley, you know, how you pulled a box with a rope through the pulley. We don't need to know all the atoms and that moved in there, and we don't need the computer for all that. Okay? Thanks to Turing and Shannon, we are able to describe, okay, and model nature in ever greater detail. Great. Love it. What's that got to do with physics? I don't know. The fact that you can describe in great detail with a computer, being able to tell you where every pixel was in the universe, yeah, fine. That's a description. You still haven't told me anything about mechanisms, about explanations, about physics. Okay? Okay. But he doesn't stop there. He just told us that it's a concept, right? Information. And now he's going to do a 180-degree turn. He says, information, far from being an abstract concept. I thought he just said it's a concept. Now he's changing his mind. He says, obeys the same laws of physics as everything else in the universe. Oh, is that so? Okay, so law of gravity, you can pull on information. Magnetism attracts information. A magnet. I don't know what he's talking about. Okay, information is not just an abstraction. Okay, just a mathematical thing or formula. Thank you. Information is carried by something. It's carried by something. It's encoded unto something. He's going to take this information, he's going to put it in some kind of box, okay? Put it in a book or a CD. There's a carrier, and that means that information behaves according to the laws of physics. He's treating it like an object. So don't accuse me of saying I'm doing semantics here. He's saying this, and that's what he's been saying for the last since I started my discussion on this. What makes information so powerful is that it can be stored in any physical system we choose. Okay? So am I playing semantics? Maybe he's doing semantics. Maybe he's bringing terms of ordinary speech, concepts, and turning them into objects in physics so that he can sneak in his religion into physics. Maybe that's what's happening here. Okay? You're going to accuse me? Please look at what he's saying. He's saying that you can store it, you can crunch it, you can kick it, hit it, strike it, beat it up. You can do anything you want with. Here we have the hobos there carrying, information. Yeah, it's not me that's using this terminology. It's him who's introducing this. Okay, and how does he end up with all this? If you can store it, and you can kick it, and you can do all these things, well, obviously you can handle it, okay? And so here he says it can be sent quickly. Oh, you better believe it. I know a little bit about that. I sent information quite quickly. We can manipulate information, okay? We can manipulate information. He's going to handle information from DNA to quantum particles. Well, I don't know about quantum particles because we don't have shape for any of them. All we see when we go to the standard model, we see the letter G and the letter E, and we got all the alphabet in there, but we don't see a single picture of any particle. I mean, what do these particles look like? Do they look like hooks? I mean, if the graviton, for example, right? Or let's use the gluon because the graviton is not even a standard model. But let's use the gluon. If the gluon attracts another gluon or attracts a quark, what is it? Is it a hook? Hook shape that hooks it and brings it in? Is that how it does it? Or is it a bed spring like, I've illustrated in the past? What does it look like? And I don't care what it really looks like. I want to know what they say it looks like so that they can explain the mechanism of how a gluon attracts a quark or two quarks together. I want to see that mechanism. What are they going to put there? Especially if they talk about pull and they say that the strong force, the gluon holds or pulls two quarks together. I need to have some elongated object there that pulls. Otherwise, I don't know. They're going to put glue in there. Is that why they call it gluon? Yeah, maybe that's it. DNA, is DNA information? I thought DNA was a molecule. I mean, if you went to another planet, right, and you found DNA lying on the floor, a big chunk of it, right? You're atom man, and suddenly you see this big molecule there. Would you say, oh, that's information? No, that's DNA. Information is what you derive, what's going on in here, not out there. Writing is out there. Information is in here. Understanding is in here. Okay? The phenomenon, whatever happened could happen out there. But that's not information. Information is in here. Is information the Morse code that the sender sent? Is information the signal that went through the wires? Whatever that is, that light or that electricity or whatever it is going through there, magnetism, whatever's going through there, I don't care. Is that information? Is information what the receptionist, the person at the other end of the end, gets the Morse codes at da-da, and what does that mean? Well, SOS, help. Is that information? No, information is what the receptionist, right? The receptor, the receiver, interprets from all that stuff. From the sender, the signal, whatever was received, the person now interprets, that's information. Okay? Information is always in the mind. It's never out here. Never standalone object out here saying, oh, this is information. Here, take 2 pounds of it. No such monster. Okay, not in physics. Okay, so let's go with a summary. Okay, here's if I can get it up here. Here's the summary. What are the fatal problems with Al-Khalili's information argument? Well, he never defined thing. He never defined concept, and he never defined exist. He uses these words constantly. Okay, so we don't know what an object is. We don't know what he means when he says anything or something or body or any of those words that he uses. Okay, he never defines what a concept is. So he says, yeah, information is a concept, and then he suddenly says, well, no, it's really an object. It's a thing. It's not an object. It's not an abstraction. It's a real thing that belongs to physics. And he doesn't define exists, even though he says, oh, information exists. What do you mean it exists? So he's using words of ordinary speech, bringing them across the line into physics. He hasn't defined any of them, he just uses them. Blah, blah, blah. Okay, so he's very poetic. He talks about spirituality. Okay, he's not talking about physics. He's talking about all these spirits, energy, mass, time, information. No such spirits in physics. Okay, no standalone such such objects in physics. He brings all this stuff from ordinary speech indiscriminately into physics. He doesn't even attempt to define any of these terms, so he just uses the words of ordinary speech. And he does reification. He reifies everything. Okay, information is reified again from info into a rock. And you say, Bill, that's not what he said. Yeah, that is what he said. That's exactly what he said. I'm not putting words in his mouth. He's putting words in his mouth. That's coming out of the horse's mouth. Okay, so I didn't put those words in his mouth. He is telling you that when a mathematician comes to town, he's going to tell you that energy is a rock, and that mass is a stone, and that time is a hammock, and that information is something solid. You can hold it in your hand, because it's out there, he says. It's not in here, it's came out. As soon as we started writing, and then we went into electricity and started sending information over the wires, and then we invented computers, suddenly information was no longer in here, now it was out there. Okay? And so all I can tell you is information is not a part of physics. Anyone using the word information is not talking about physics. Therefore, Mr. Al-Khalili is not a physicist. He is whatever he is. I don't know. He's a monk, born-again mathematician, just spreading his religion to the public. That's all he is on behalf of the BBC, and with powerful interests behind. Anyways, here's another part of that. Okay. Okay, it's not DNA. We'll get to that. So what is information? Okay, info is not what the emitter sent. It's not what the signal that travels through the wires, and it's not what the receptionist of the Morse code gets on his or her device. Information is the interpretation of the analyst makes in his brain of whatever he sees out there. So it's not that information is out there, information is in here. Information means that you're going to process, you're going to analyze whatever you saw or heard, smelled, tasted, and you're going to process it somewhere in your brain, all those neurons in there. They're going to, the machinery is going to go on, and whatever it produces in there, that's information for you. Okay, now you spit it out and you say, okay, this is the information I have in my brain, the idea, the concept, whatever you got. So you send it out. Now I hear it or I see it on the board, right? So it could be different ways. And I have the same process. I absorb all that through my senses, penetrates all the way to my brain through all these neurons, right? And once it's processed in there, now I have information as well. So information is always in there. Never leaves the brain. Okay, information doesn't leave because it can't travel. Information has that peculiarity that it cannot travel. It's not an object. Only objects can travel in physics. So whatever I think, whatever's being processed in there, okay, I call that result information, which is just a process of thinking. Okay, when I spit it out, again, I'm not spitting out information. What I'm doing is spitting out sound and something that you can see, maybe, maybe a video or something on the screen or whatever. And you absorb that again through your senses and you process it in your brain. And now you produce what we could call information. Information is a process of thinking. That's all it is. Okay? Information is always in the brain. So we can't talk about information being out there. Writing on a wall is not information, especially for the guy who cannot understand hieroglyphics. I mean, if a Martian came to Earth, they visited us, In the days of the Egyptians, they built the pyramids. Okay, well, when they came over and they saw those hieroglyphics, they, well, what are those? Is that art? They probably didn't know what it was, would they? I mean, as far as they're concerned, those are just what hieroglyphics, whatever those are, just drawings, right? Okay, so it's not information. It's just a little drawing on the board. Information is in here only if it makes sense or you get something out of it, you process it. Okay, even a robot does not understand the information. Information, the robot cannot tell you what light is, cannot infer or deduce, cannot give you an answer to that. A robot can only spit out what, garbage in, garbage out. If you program the robot to think of light as photons and to treat them as particles or whatever, well, whatever signal the robot sees or whatever, the robot's going to come out and say, particles, particles. The robot's not going to tell you, hey, no, you've been wrong all these years. Mathematical physics is garbage. Light is mediated by a rope that torques. No, the robot cannot tell you that. Okay? Sorry, that's got to be done by living entities. And so even a robot is not a source of information in that sense. It doesn't create ideas. It doesn't come up with any idea that you haven't put into it. Now, you can say, well, it puts one and one together and comes up with two. Maybe it does it faster. Can it come up with an explanation? Can it tell you what gravity is? That invisible stuff. No, you got to somehow program it in there. The robot's never going to infer, deduce that invisible thingy that's doing gravity. Because assuming it did, you wouldn't believe it anyway. So something's wrong with this computer. You wouldn't believe the robot says, it says that it's a rope that's pulling these atoms together. Oh, something's wrong with this guy. So no, the robot cannot tell you about the rope model. You got to program it into the robot or the android or whoever, the cyborg. Okay, robot spits out what was programmed into it. Okay. Anyways, that's my take on Al-Khalili and his notion of information. Everything he's got to say on information. No such monster in physics.